Hi guys, welcome back. The video you're about to watch is dealing with logarithmic differentiation, and this is for my calculus class out of section 5.1. Just going to do two quick examples, and logarithmic differentiation is a shortcut pretty much so that you don't have to use the chain rule and quotient rule or product rule so many times that the algebra gets really complicated. This actually makes taking a derivative of a complex rational function a lot easier. There are four simple steps right here where you kind of have the same systematic outline every time. You're going to take the ln of both sides. Alright, so down here I got a function of y equals x minus 2 quantity squared, square root of x squared plus 1. If we were to do this the way that we know leading up to this, well, we'd have a quotient rule and we'd have a chain rule within this, and so that would we could do it, but it would be a little bit messy. So I'm going to look at step one here. Take the natural log of both sides. All right, that's easy enough algebraically. I'm going to have the natural log of y equaling the natural log of x minus 2 squared all over the square root of x squared plus 1. Okay, that was pretty easy. Now let's take a look at step two here. Simplify both sides. Simplify using the properties. Okay, so now what I want to be able to do is expand this right side here using the properties of logarithms. And if you recall, like your quotient implies subtraction, power rule, multiplication implies addition. All right, so my left side is going to stay the same. I'm going to have the natural log of y, and then I know I have a quotient here, so I'm going to have the natural log of x minus 2 squared, and then minus the natural log of the square root of x squared plus 1. And still expanding here, I know I'm going to have the natural log of y, and then the power rule allows that to come down here. So I got 2 natural log of x minus 2 minus, I'm going to have 1/2 because of the square root here, natural log of x squared plus 1. Alright, so that's fully expanded. Alright, let's take a look. Step 3 here. Take the derivative of both sides using implicit differentiation on the left. Okay. So the derivative for, let me scroll up here just a tad. The derivative on the left side, well, the derivative of natural log of x is 1 over x. Well, the derivative of natural log of y is going to be 1 over y, but it's implicit, so I got to multiply this by dy dx. Okay, and then we're going to have 2 times the derivative of this, which is 1 over x minus 2. Inside goes in the bottom, derivative of that goes in the top, minus 1/2 times the derivative for this log, so in the bottom is going to be the x squared plus 1, and the top of this is going to be 2x. Okay, and the last step here, replace y with the original function. Now what that means to do is here, we're trying to solve for dy dx, the derivative. Well, that's this part right here. Okay, so I need to multiply both sides by y. So if I multiply both sides by y, we will see that this cancels with this, and I'll have my derivative. So dy dx, the derivative, is equal to, now I use a big parenthesis here, I'm going to have 2 over x minus 2 minus, and as you can see right here, I'm going to just do a little simplifying here, the 1/2 and the 2 would cancel. Okay, and I'll have x over x squared plus 1, and I got to multiply by y. Well, y was the original function, so that's all of this right here, so I got to multiply by the quantity of x minus 2 squared over the square root of x squared plus 1. And this whole thing right here, this is my derivative. And that was a lot simpler than trying to do a quotient rule and a chain rule and worry about combining like terms and all that. This whole thing right here is my derivative. Now you got to make sure at the very end here what we did. Number one mistake I always see on tests, people do the nice expansion in the derivative with the logarithm part. They always forget to multiply by y at the end. So make sure you do this part right here at the end by multiplying by the y. Let's just do one more example. Alright, so again, first step, take natural log of both sides. So I got natural log of y, natural log of x squared, x plus 2, all over the quantity of x minus 6 cubed. Alright, expand using the properties. I'm going to come down here. Natural log of y, I'm going to have the natural log of x squared, x plus 2, minus, because of the quotient, natural log of x minus 6 cubed. And I still have a product going on here, so I still got some expansion to do here. Natural log of x squared plus the natural log of x plus 2 minus the natural log x minus 6 cubed. And then my last and final step is any powers have got to come down. So natural log of y, 2 natural log of x, no power for this one, so just natural log of x plus 2, and then minus 3 natural log of x minus 6. I'm not sure why I put the extra parenthesis there, but I did. And now take the derivative implicitly on the left side. The left side's always going to be 1 over y dy dx. And this is going to wind up being 2 over x for the derivative. 2 times derivative of natural log of x is 1 over x. Plus x plus 2, the inside goes in the bottom. Derivative of that goes in the top. Minus 3, x minus 6 goes in the bottom. Derivative of that is 1, goes in the top, so 1 times 3 is 3. And then my final thing again, you got to multiply both sides by y. And again, y was the original. There's your y right there. Okay? And so your final answer, dy dx, is equal to 2 over x plus 1 over x plus 2 minus 3 over x minus 6 times the original of x squared times x plus 2 all over x minus 6 quantity cubed. So that's the derivative. And then remember, what can you get from the derivative? You get the slope. So if they gave you a point to plug in, you would plug in the x value to get the slope at a certain point, things like that. But wanted to show you 2 quick examples there of how to do logarithmic differentiation, and helps for the review from your homework and review for the upcoming quiz and test. So thanks for tuning in, and we'll see you the next time.